Thank you for joining this episode of our webinar series on best practices in e-discovery. Today's session is focused on solving the challenges of reviewing large email sets and the top 10 things the boutique lawyer needs to know. My name is Jeff Fugit. I'm Vice President of Sales and Marketing for Lexpe, and I'll be the moderator for today's event. Our webinars take place monthly and cover a variety of relevant e-discovery topics, trends, best practices, and strategies. Space is limited to the capacity of our webinar platform, and with the popularity of this series, with more than 5,000 people participating last year, I recommend registering promptly for the sessions that are of interest to you. If you have technical issues or questions, please email us at webinars@lexpe.com and we'll address them right away. Our webinars are available online at lexpe.com for viewing via streaming video or downloadable as a PDF presentation or MP3 podcast. You'll find this webinar and a complete listing of other webinars at lexpe.com. To be notified of future live and on-demand events, please email us at webinars@lexpe.com or follow us on LinkedIn. So a little bit about Lexpe. Based in Austin, Texas, we provide a very affordable cloud-based e-discovery platform and services. We specialize in equipping the boutique firm with an e-discovery solution that gives them full control over the e-discovery process, complete DIY capabilities, and incredibly fast performance. We're the industry's most affordable and full-featured DIY e-discovery platform. We have the industry's fastest e-discovery processing and document review platform. We deliver the industry's fastest ROI as designated by G2 Crowd in a study that was done last year. We have a team of experienced e-discovery specialists and consultants who are ACET certified and ready to assist clients on a moment's notice should they need it. And if you'd like a demonstration of our platform, simply email us at sales@lexpe.com and we'll get that scheduled. Joining us today is Karsten Weber. Karsten is co-founder and CTO of Lexpe. He is an accomplished software architect and visionary with over 20 years of experience leading software development teams. His expertise spans multiple programming languages and includes advanced capabilities in artificial intelligence and machine learning. Before I turn it over to Karsten, I'm going to share with you some of the trends in ESI and particularly in email. And so we'll get into that and help kind of set the stage for Karsten's presentation. By 2025, we will have eclipsed 160 zettabytes of data. And not only is data growth exponential, but it also is fragmenting across a growing number of channels. So we're going to drill into some of the details of this fragmentation. Email, as a part of that growth, is expanding at roughly 5 to 6% annually. However, with 3.7 billion email users and daily emails sent growing to almost 320 billion by 2021, it's certainly a massive amount of data. Many litigators have come to rely heavily on email, and rightfully so. The evidentiary risk associated with email is so much so that GCs and CIOs are limiting their exposure through data governance. A lot of organizations are limiting the amount of email stored, and some have done away with archiving PSTs. So the number of email accounts per user is also on the rise with 1.8. This is an important consideration when developing your ESI preservation and collection strategies. Perhaps during your custodian interview, you've asked them about their business accounts. However, you need to also ask them about their personal or other accounts that they may access at work. To focus in on the specifics of your case, you'll also want the context of the emails, which could include code words, acronyms, abbreviations, project names or nicknames, nicknames for people, file naming conventions, critical dates, and file storage methods and locations. So to reiterate, you really need to develop a custodian data mapping process and not anticipate that email alone will get the job done. Email is an incredibly convenient digital repository for people. Even with millennials preferring group chat and instant messaging over email, email isn't going away anytime soon. In addition, there are popular email clients like Mailbird that integrate email with a bunch of other apps like Slack, WhatsApp, and Facebook's Messenger. And so we're seeing more and more an integration between email and other messaging and communication channels. Because of the proliferation of messaging apps, you also need to expand your sites when it comes to ESI and not just focus on email. Here's a perfect example of why you need to expand beyond email. There's been a huge growth in mobile messaging apps. WhatsApp leads this group with over 1.5 billion monthly active users. I've spoken to litigators on several occasions, and they've not heard of Line or Telegram yet, but those apps have more than 400 million monthly active users. The usage of mobile devices and the complexity of the mobile IT ecosystem goes up significantly with millennials. So it is important to understand the makeup, character, and quality of the custodians and craft your interview strategy accordingly. If you're in intellectual property, product liability, or labor and employment practice areas, you'll certainly want to pay attention to this slide. Collaboration apps are in high growth mode as organizations tap into global workforces and look to maximize productivity and speed to market. Also not represented on this chart is Cisco Jabber, which had a strong presence with larger enterprises. When interviewing custodians, it is important to bring up these channels of communication because they might not always think about them in terms of repositories of relevant case data. We've also seen frequently that employees feel less inhibited when communicating through these applications, and therefore they're frequently significant sources of evidence. Beyond collaboration platforms and facilitated by mobile devices is Shadow IT. Shadow IT is information technology that is typically purchased and utilized by an employee without explicit organizational approval. There are thousands of popular applications that include messaging and/or data portability, like Dropbox. The ability to sync a mobile device or USB drive with hundreds of gigs of capacity also poses an ESI challenge. Luckily, today we have Karsten Weber, who will walk you through some of the critical steps to identifying the issues associated with email and walk through the top 10 things that you need to know about email, and will assist you in solving these challenges. Before I turn it over to Karsten, I do have a polling question, a couple of polling questions that I'm going to ask for your participation in. The first one is, what percentage of your matters involve reviewing large email sets? So I'll give you a little bit of time to answer that. So if you could do that, we would certainly appreciate it. And I'll take this time to thank you for participating in our polling questions today. And then our next polling question, do you use data mapping during your custodian interviews? And that is yes, no, or what is data mapping? All right, I'll go ahead and close that poll. And without further ado, I'll turn it over to Karsten Weber. Karsten?
Thank you, Jeff, and welcome to the webinar on top 10 things to know about email. Today we will be covering several parts. We'll start out by talking about how email exists in many places and they're practically impossible to get rid of. Then we'll talk about the hidden part of the email message and how that can be used in litigation. After that, we'll talk about the time zone offset, how that affects review. Move on to horizontal versus vertical deduplication, talk about what that is and the best way to use that to cut down on the amount of data that's being reviewed. Then we'll look at email threading and near duplication. Talk about how all the previous steps can lead up to speeding up the review. How email should be handled from a searchability standpoint. And then end on talking about the dangers of producing native emails. So let's get started. Here's an example of the very first email that was ever sent. You can see it's from 1971. And so emails have been around for quite a long time. This is the first row of letters on the keyboard. And if you ever wonder why we chose that kind of layout or why that layout was chosen, it actually dates all the way back to the old-fashioned typewriters that had hammers, and they were laid out in a way that letters that were used frequently together wouldn't actually jam those hammers. So that's why we're left for historical reasons with a very odd layout, but that's what we're using. 1 gigabyte of email is roughly equal to 50,000 pages, or if you were to print them out, it would be 15 banker's boxes worth of papers. And we see quite frequently custodians with 10 gigabytes of data, so that's 10 times as much, or 500,000 pages. So just one person you collect as a custodian can result in just a significant volume of data. This next slide shows how over the years the amount of physical mail has actually peaked in 2007, it looks like, and then started declining, whereas emails just continued to increase, and we're around 300 billion emails sent every day in the world. This next one shows an example from a real life case where the smoking gun was found in an email. So emails are just increasingly the critical evidence in cases, and that's because there's so much of it generated in the company. By one estimate, 28% of an employee's daily time is spent reading and writing email. So it contains a lot of potential evidence, and one thing that's interesting is you often see email threads, and once they know that they're discussing things that are very sensitive, they'll use words or phrases such as, can we talk about this offline, or call me? And so those can actually be really interesting things to search on within your email set. So search for things like call me, take offline, and you'll often find the email threads that are most interesting. Okay, let's talk about emails and how they can exist in many places and why they're so difficult to get rid of. First off, I mean, there are several different providers of email. While they all have to follow the same fundamental protocol in order for them to be able to talk to one another. Each company that provides these emails will have their own implementation. They'll have their own servers, they'll have their own infrastructure. Quite often they'll choose an approach where all the emails are stored on servers in a central location, and then all of your devices are now able to sync up, so that if you send and receive email on your mobile device, it will be reflected on your browser version or your desktop version. Whereas in the old days, it was much more of the POP protocol, the post office protocol was such that if you send it on one device, it would not automatically sync with the other. Let's take the Microsoft Outlook as an example, because it's quite dominant in the industry. They have their servers. They use a file format called OST files, and then locally, when you connect to them, a lot of people will use Microsoft Outlook, and it will generate what's called a PST file. So it's a file that actually has the extension .pst, and it will contain all of the emails. So earlier we were talking about a custodian having 10 gigabytes of email. They'll have one file, a PST file, that is 10 gigabytes in size. And you can think of that file somewhat similar to a zip file. So it is a one file, and let's say it contains 50,000 emails, then all of those emails exist inside that one file. And only Outlook is, you can't open it on your machine directly. You have to use a program like Outlook to open it. And then once it's open, you can view the emails, you can save them individually. And if you save them individually, each email will be saved as an MSG file. Google's Gmail is becoming quite dominant as well. And while they don't use the PST and the MSG format, they use an inbox instead. You're able to take the inbox similarly, and you can export it, and you can use various tools to convert that inbox to a PST at that point. So a lot of the collection is still being collected as PSTs, even if they're collected from one of these other providers, be it Gmail, be it Yahoo. You can also take Outlook itself or some other email collection tool and point it to a Gmail account or Yahoo account, and then pull down a PST for collection. So with all that, you can see that the email itself can exist in a lot of different places. It can exist on the servers. It can exist on your local machine. It can exist on your phone. Once it's on your local machine, you may have a backup software that then archives it locally, or you can have a backup software that backs it back up to the cloud. That email that you sent is also in the receiver's inbox. It will very quickly be in a lot of different locations, and there is no good way or there is no practical way for you to pull it back at that point. It's out there. If you go into, this example uses Outlook, and you take your incoming messages or the ones you've sent and you put them and you say delete this message, again, it doesn't get rid of the data. It just merely takes that email and it puts it into the recycle bin here. And then, so they're all visible if you click on that icon. Even if you go in and you say empty the deleted folders, what Outlook does is it doesn't actually delete that from the hard drive. Instead, it just marks within this big PST file, it marks this email is now deleted. It don't use it anymore. It's actually still there on disk, and you are able to recover it. So the only way to really get rid of it at that point is to use their free utilities. A BleachBit is one. AcidWatch is what they're called as well. And even though they're called AcidWatch, they're not using chemicals. They're just going in and actually setting all the bits on your hard drive to 0 for that particular area. And at that point, the file is really gone. But it's really gone from your local hard drive. It's not gone from the backup version. It's not gone from the server version. It's not gone from the receiver, and so on and so forth. So in practice, once an email has been sent, it's impossible to get rid of it. So that's good news for a case. It means that you will be able, when you collect it, you will most likely be able to find a version of the custodian's emails, even if they have tried to locally remove them. Okay, let's move on and look at the header information on emails. So an email consists of, we can think of it as two parts. There's the visible part, the one you open when you see your email, and it says to, from, subject, date, and then the content. And then there's the invisible part, which you can get to, but it's not displayed by default. And that is the header information that every email carries. And that you can get to it if you're in Outlook, for example. You can go onto the file menu, go to properties, and then ask to see the properties of the internet header. And here's an example of that content. And it will show information such as the IP address of the servers that it went through, information you wouldn't normally see. It will also contain information about the message ID, references, and reply to. Those are certain fields that are part of an email standard, and the references in particular can be used to see all the previous messages that this email has gone through. So that's great for email threading. We'll talk about that later. But if you, for example, receive an email, hit respond, remove all the content, just make it completely blank, write a new message, and then hit send, it will still say, hey, this was a reply to this previous message, and it will keep all that tracking inside it. So if you don't want to keep generating these email links. It's better to just hit new message each time. Here's an example of how the fields from that internet header is pulled out and then fielded into a review system so that you can easily see who it's from and when and where. And then one last thing on the email header is just be aware that it doesn't take a genius to go in and modify these. So you can actually receive an email. Here's one that says it was sent from the FBI and saying hand over all the documents. But then when you look at the internet header, you can see that it is indeed not sent from the FBI, and you're able to spoof the sender. And it's just something to be aware of. If you're in litigation, you have a document, this is really key. You might want to double check that it hasn't been compromised. You do that by looking at the internet headers and make sure that is indeed the sender. Okay. Let's talk about, let's change gear and talk about email time zones. This is very interesting. So the servers that handle all the email, they don't necessarily know what time zone that you're in. And so they tend to store everything in universal time. And that means if you send a certain email, then again, using Outlook as an example, Outlook will say, well, you just sent it and say it was 1:03 p.m. that you sent that. So it will show us 1:03 p.m. But then if you very quickly take this thing and you travel with Outlook in your computer, you travel 2 time zones to the west. So you're 2 hours earlier and you open that exact same message in Outlook, your computer will reset to that time zone and now will say, you sent this email at 11:03 a.m. So just the exact same email on your same computer in Outlook will just have changed the timestamp of when you send it. Another way of saying it, what Outlook will display depends on what time zone you're currently in. And that makes it very tricky when you have emails collected from different time zones in terms of trying to line them up. Was this email sent before or after that email? The time zone can really mess up that comparison. So that's the problem. What's the solution? Well, there are a couple of possibilities. One is to just have each custodian is collected and you say what is their predominant time zone. I mean, they could be traveling as well, but what was their primary time zone? Or you can use a single time zone for all custodians wherever the case is being litigated or where the business headquarter was. Or for more complex cases, you might just simply go to universal time and say, we're going to store all the emails in universal time. It does mean that it's going to look like there's a lot of activity at night if it's a US-based case because of that time zone offset to UT. It's kind of skewed, but it solves a lot of problems. Everything now lines up. All the email threads are in the right order. And we have one case where the client was trying to, I mean, I don't want to say insisted on, but we're really trying to not use UT, but come up and correct for everything to be local time, spend weeks and weeks on that, and in the end say, this is just not going to be possible. They ended up with issues such as documents that are printed out and stored in a warehouse. Now they get scanned in. What time zones do they get assigned to? Was that where the warehouse was? Was it where the documents were printed out? It just became too difficult to really keep good track of the local time zone. And the solution was to simply do everything in universal time. Okay. The next topic is about the horizontal versus vertical deduplication. And before we can talk about that, let's talk about some of the fundamentals of how we get there. We will often see in big cases that there are a lot of duplicates of emails. So one basic example would be you're collecting from 10 different custodians from the same company, and all of like the broadcast emails, the emails that are sent to everyone in the company, every one of those 10 people will now have that same email in their inbox unless they've deleted it. And so when you collect all of those, there is no point in having to review that 10 times. I mean, it would be better to get rid of those. How can we safely get rid of data without accidentally deleting things that are key to the case? And it's done by calculating hash value. So this is how it's technically achieved. You create a hash value of a file, which is like a fingerprint. A file, any file, no matter what type it is, just at the fundamental level consists of ones and zeros. And these algorithms will take all those ones and zeros and then they'll do some fancy finite field math in order to reduce that down into just the hash of that, a short digest of that longer set of numbers. And a very popular one is the MD5, which is 128-bit hash. SHA-1 and SHA-256 are also in use. As the number of bits go up, so does the computational intensity to calculate these. And so we want to have a balance between what is fast to compute, but what is also enough bits to make it secure. And the difference between 128 and 160 or 256 may not sound like much, but every time you add a bit, you double the number of possibilities. And just to give you an example, the hash with 256 bits, there are so many combinations in 260 bits that it rivals the number of atoms in the universe. So that's quite a big number. So we use this hash value for chain of custody, but also in order we can denist, so we can remove things that are known system files. So unless the case is about Microsoft Windows operating system, for example, you can remove all the files that we know matches the hash value of those system files. Now, deduplication now becomes a task of comparing all these hash values. And if two files have the same hash value, they are indeed the identical document. If you create a revision of the document or any slight modification, it will have a completely different hash value. And vice versa, if it has the same hash value, it is mathematically the same file. So should we just go in and remove anything that has the same hash value? I mean, that's one approach, but as you can see here, we need to take into account custodians. And here's the problem. The problem would be a case where you have the same document in two different people's email. So custodian 1, custodian 2, they have the exact same email. And now you remove one of them, or even a better example would be that one where it's broadcast to 10 custodians. Let's take that. It's broadcast to all 10. We remove 9 duplicates, we keep 1. We just choose a random one to keep. And now the case goes forward, and after a while, it goes, wait a minute, these 10 are not the right custodians. We need to add 2 and we need to drop 1 or 2. And then if we happen to drop the 1 that we left the only prime document in, now that particular email is completely gone from the collection. And so it just becomes really difficult to keep track of which one can I safely delete. So for the longest time, the best approach was to do a vertical dedupe. If you do a vertical dedupe, that means just within each custodian, you can go in and remove duplicates. So in our example here, custodian 1 has that green document twice. It's safe to remove one of those screens. Custodian 2 has that same document as well, but we'll leave that in just because if custodian 1 or 2 was ever removed, they're like self-contained. Drawback is that it doesn't delete things as well as it could. Our example with 10 people that received the exact same email under vertical dedupe, all 10 emails remain. There's no reduction. So that's an example of how bad vertical dedupe can be, but it has a lot of benefits. What's becoming more and more the industry best practice is now horizontal dedupe, where you do remove all but one of the documents. But to avoid the problem of accidentally removing it from the set, if our custodian is dropped, a record is now generated, a log that says, here are all this document was removed from all of the following custodians. And so in our example from earlier with 10 emails sent, or emails sent to 10 custodians, it would be a reduction of 9 emails would be gone and only 1 would be left. And so, factor 10 in reduction of review time. Let's talk about dedupes and email threading. So we just talked about exact duplicates, mathematically identical documents, and so it's completely safe to remove it. Near duplicates is where the documents are very similar, but they're not identical. And you can take all of your unstructured document and you can move them into near dupe groups. Some documents will not dupe. It really is one of a kind, but there are lots of documents that will group because it's similar log files, it's similar emails, like in an email thread. If you send a document and somebody else responds, that looks good or sounds good, or I'm calling now, well, then they're going to near dupe. It's looking at the text content of the document and comparing that. In addition to the near dupe group, we have email threading, which is looking at these internet headers we talked about earlier and using the referrer to make sure that these really are in the same email thread. And so very often you will see the near dupe and the email thread pick up the exact same document, because it really is, it's the same conversation and it's just changing a little bit from every reply as the conversation grows. But there's one big difference, and that is in email threading, if you took that email threading and now you printed it out and then you later scanned it in, or for whatever reason it left its ecosystem of email, it came out and now it got scanned or printed to PDF or whatever, and then pulled back in. That scanned document or the printed to PDF document no longer contains the header. The internet header, the hidden one, is gone, and it will not be able to email thread that. It won't be able to link that up with the thread. However, it will be able to hook it up as a near dupe, because it will be the same or text-wise as one of the emails. And so that's an example where email threading and near dupe are complementary, and near dupe would do better in this example. This slide shows various group sizes for near dupe. And so in the biggest one here, we have one group that contains 80 documents. And so while they're not identical, they're near dupes, not exact dupes. Chances are still that if one of those documents is privileged, for example, then all of them would likely be privileged. And so you can use these near dupe groupings. You can use email threading to really make sure that previous documents are all marked correctly. This one shows a browse view of the same, the Neodupe group. And you can see just, I mean, the title is very similar. So this is likely a threading group here we're looking at, picked up by using Neodupe. So as we saw earlier, Neodupe and email threading are really complementary in terms of your review. But there's one thing that's specific to the emails, and that is we know exactly in what order they appeared. So for example, if you launch out an email, you're the root of that email. And if you send it to another person and they reply and then you reply again, you're creating a chain of emails. But if you send it to more than one person, say you send it to 2 or 3 people, it's more than a chain, it's more like a tree, where you can start with one root, that's the person that did the original email. And if you send it to 2 people, that'll branch into 2. And depending on how they respond, it may continue as a single thread, a single chain, or it might branch again. So we're able to take all this information and depict it in a graph. And the graph is what's shown here in the next slide. You're able to see the root email, that's the first one that was ever generated in this example, is then sent to 2 people, and they respond to it. And in one case, there's a response to 2 people. All of that is kept track of within the email. And we even have the ability to go in and find missing emails. So we can see in this example that there are 4 missing emails. So according to the header information, the hidden information in the email, there should be these 4 emails that do exist, but they're not part of the collection. They've not been imported into this case. So it's a very powerful way of making sure that you have collected all your custodians, that all the information is present in. Another very important feature is we have the ability to indicate if a given email is a superset of the previous email. So if you have a single chain and all of the emails are available, and let's say it's a conversation between 2 people that have gone back and forth 10 times, if every single one of those emails is a superset, then you only have to review the last one, because the text content of all the previous emails is available in that last one. That will save you a significant amount of time in terms of reviewing. If you go in, you can select multiple documents here and you can do mass tagging. But if you go in and select 2 of the emails, you'll be able to then click on a compare view, and that's shown here in the next slide, where it will show you exactly what was added to that email. So in this example, it will be in the reply. You can see what the new information is. And so this will be a very effective way of seeing what changed. You can either do all the lines, or you can show only the lines that have differences. So if you have a very long document and there is a difference that's further down, I mean, you can see just the lines with difference, and that will, again, make it more compact and faster to review. One thing where in this email chain is I have the habit of, if I respond to somebody I haven't talked to in a while, I'll just find their last email, I'll respond to it, but then I'll remove the content of the body and I will change the subject and then start a new thread. To me, it's a new thread, but as far as email threading is concerned, it's a continuation. It still knows from that hidden header information that I'm replying to the previous email. So even if I remove all the content and start something new, or they have removed all the content and just responded, this looks good, I agree, the email header information will keep it together. And so this is one example where email threading is better than Neodupe in terms of keeping things together. The Neodupe would not have identified these 2 documents as belonging together if I removed all the content and just said, looks good, they're just textually too different. So again, NeoDupe and email threading are complementary, and this was an example where threading would be better than NeoDupe. Okay, so let's talk about how all these different techniques can be combined into speeding up your review. The NeoDupe, the dedupe, the email threading. Basically, we'll receive the emails and we'll pull out all of the information if we have the natives. We'll field it into a review system so that it can be easily filtered and searched. Next one shows the type of fields that you would receive if you're not receiving the natives, or even if you are, but you're receiving it as a production. Then there will be a file, a load file, like a DAT file that comes in, and that will contain all the fields like date sent, date received, sender, receiver, email. All that fielded data should be present, and you need to make sure that, I mean, this is just a small example of all the fields. That could be 50 to 100 fields, and you need to make sure that you ask for as many of those fields as possible. Or even better is you get the actual native files, because then you have the data and you can pull it out, or the review system can pull those out. Once you have that in the system, you'll be able to see the emails. The emails are kept together with their attachments. You got the groups, you got the email threading, and you'll be able to do mass coding, as I'm showing you in the next slide, where for a given document, you can now update many documents at once. And that will significantly cut down on the review time and also make sure that that things are coded consistently, so that your privileged documents, for example, are all coded consistently. Finally, the screen shows how the privilege log can be automatically built within a review tool based on how things are coded. Let's talk about searchability for emails. So the email itself, the email body, will be text and very often will be fully searchable. But the email attachments, in many cases, will not. And so you could, for example, have an email that has a TIFF image, like a fax, if anybody uses those anymore. But it could be an image-based PDF, and now that is not searchable. And so what needs to be done is you need to take the email, expand the attachments, and then apply OCR to make the document searchable again. So we apply the optical character recognition and turning that image-based PDF back into a searchable PDF. The best way to make sure that you get everything searchable in your email is to use a combination of extracting the native information, the metadata, and getting the text from OCR documents. This graph here shows if you have any kind of a native extraction, it will get hidden text. It will get the text that are coming out from the document, even if the print region is set to smaller than the text. It gets all of that, and then but it doesn't get the image-based. And then you take the OCR with the image, and you get the text out of those documents. And then which of the two text sources should you use? Should you use the meta one, or should you use the image-based one? As you can see, either one will have a limitation. And so the best approach would be to use a dual index, or an Uber index, as we call it, that will combine those two into one search. So now when you search for a given field, like in this next one here, where we're searching for first one document. And it doesn't care if it has it in just the text part or just the image part or in both. It will find that document, and then it will, as is shown here, will easily display where you can just switch between the HTML tab to see that view or the text tab, in addition to looking at the PDF or the original. The final slide is about being careful about producing native emails. So if you're on the receiving end, you should absolutely request the native emails, because there's so much information in there. And if you have the originals, that will be very powerful. Similarly, when you're on the producing side, you want to be very careful to produce native emails. So a very simple example would be, you got your email, you got your attachments. One of those attachments is privileged. So you don't produce that attachment, but of course the original email still is the original email. It has all the attachments, including the privileged one. So your system needs to make sure that it understands that relationship. It doesn't produce that original. And but even safer or better would be to simply not produce any emails at all unless required. If we can do in addition to just the pure native production, you can do a TIFF production. That means you've taken all the images, all the documents, and created images of those. Those are compatible with going all the way back to concordance and summation, and are compatible with just about any review platform out there. One of the drawbacks is they tend to be 8 to 10 times bigger in size than the originals, and so there's just a lot more data to carry around. Slows down the process somewhat. Or you can choose a PDF production, which is now sort of the combination of both. You get a very controlled document. What you see is what you get. You don't have any hidden disclosure from the original, but you don't have the bloating of the size of the TIFF production. Best practice is to produce the emails converted to TIFF or PDF, so that you can base stamp and redact it, and then only do the native versions of non-privileged attachments in email when it's actually required. And with that, I'll hand it back to Jeff. Thank you.
Thanks, Karsten. That was a fascinating presentation on the top 10 things to consider when reviewing large email sets. I'm going to cover a little bit on Lexby, and then I'll ask our last polling question. Lexby is uniquely positioned to help boutique law firms and organizations that want to keep e-discovery in-house solve for the challenges of large and growing email sets. We equip boutique firms with the most efficient infrastructure, expertise, and advanced capabilities. Lexby really facilitates the mantra of lean and mean for the boutique firm. With on-demand, cloud-based e-discovery, you not only have leading-edge technology performance and security, but it's a fraction of the cost of dedicated on-site infrastructure of your big law competition. Lexby auto scales to ensure we get you from email ingestion to review faster than anyone else. The Lexby Discovery platform can be easily accessed by virtually any internet-capable device, including PCs, Macs, iPhones, iPads, and Android devices, although I probably wouldn't recommend reviewing large email sets on iPhones. That could be a bit tedious. Lexby equips you with state-of-the-art technology that's super simple to use, so you don't have to have dedicated IT support or litigation support professionals on staff in order to have advanced e-discovery operations. Only Lexby equips you with the Uber Index. This is a highly advanced index that is comprised of native characters that get extracted from the documents upon ingestion. We create a PDF and automatically OCR that, so you get those OCR characters, as well as translated characters. Having native and OCR characters in your index is critical, as Karsten pointed out. It's very important with dealing with large email sets, particularly because there are several use cases that require both of those steps in order to assemble a complete data set that contains the evidence and privileged documents. So you want to make sure that your index has both, and LexB will equip you with that with the Uber index. In addition to the Uber index, LexB also equips you with advanced technologies that are really instrumental in reviewing and coding large email sets. The LexB discovery platform includes advanced email threading, near-dupe groupings, which I find particularly powerful, especially when dialogues cross communication modalities, and then technology-assisted review for addressing very large document sets in a timely fashion. LexB's email thread visualization capability has great utility in that you can zoom in or out of large email threads, you can select emails and view the metadata, and you can quickly identify where there are missing emails that could have been excluded from a collection or production. LexB also equips you with the ability to quickly compare emails side by side and identify the differences via colored highlighting. In addition, LexB provides the support and professional services in the event that you need them. Therefore, you don't have to have a large litigation support department or IT staff to operate eDiscovery in-house. Lastly, I'll let you know that we are the most affordable, full-featured DIY eDiscovery platform. We don't charge user fees, we don't charge case fees, we don't charge a setup fee, and you can get started for as little as $5 per gig per month for a 50 gig subscription, or you can start at $15 per gig for a month-to-month flex plan with no term commitment. And with that, I'll ask our last polling question, and that is, would you like a demonstration of the LexB eDiscovery platform? While you're answering that, I'll thank you for attending today's session. We'll be making the following available to webinar attendees: a recording streaming version, an MP3 podcast, as well as a PDF. Please let us know if you have any questions or comments about this webinar or suggestions for future topics. You'll see that on a survey at the end of today's event, so we greatly value your input there. This webinar is part of the LexB eDiscovery webinar series. For notices of future live and on-demand webinars as part of this series, please email us at webinars@lexb.com or follow us on LinkedIn. And watch your inbox for an invite to our next webinar on best practices in eDiscovery. Take care.